Today we are going to look at our second type of conic section, which is the ellipse. Here are some key points on what we call the focal axis of an ellipse. Notice how we have a vertex, a focus, a center, a focus, and another vertex. So we have two vertices, we have two foci, and the center right in the middle. These 5 points are always going to be lined up on what we call the focal axis. In this case, where the ellipse is turned horizontally, that focal axis is going to be horizontal. We can have ellipses turned vertically, where these 5 points would be lined up on a vertical focal axis. Our technical definition for an ellipse is the set of all points whose distances from two fixed points, which we call foci, have a constant sum. And we are going to see a demonstration in class tomorrow to help you understand that definition dealing with the two fixed points and the constant sum. Here is our standard equation for an ellipse. It is x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. So you notice that it looks kind of similar to the equation of a circle with the h and the k, but the difference here is that we have a bottom of a fraction, a squared, we have another bottom of a fraction, b squared, and this equation is equal to 1. This equation always has to be equal to 1 in order for us to pick out the important objects. If it's not equal to 1, then we're going to have to fix that, and you'll see an example of that here in just a minute. Now, these numbers underneath these fractions are the different radii for the ellipse. The A is what I like to refer to as the x direction radius. The x direction radius. And this B value is the y direction radius. Now, with a circle that we looked at yesterday, your x direction radius and your y direction radius were the same. When you graphed a circle, you plotted the center, and then you counted to the right and to the left and up and down from your center the exact same amount, and that's how we end up with a circle. With an ellipse, those x direction radius and y direction radius numbers are not going to be the same. If they are the same, then what we're dealing with is a circle. So those are going to be different numbers for an ellipse. The important objects in this equation, of course, our center, HK. We have vertices that we talked about on the last slide. All right, so on my picture up here, I'm going to estimate center would be about right there. Furthest points away from your center on your ellipse are your vertices. So there's a vertex to the right, there's a vertex to the left. Those are the furthest points away from your center on your ellipse. Then we have what's called co-vertices, and I'm labeling those now. There's a co-vertex down here at the bottom. There's a co-vertex up here on the top. So where the vertices are the furthest points from the center, the co-vertices are the closest points on the ellipse to your center. Foci, remember, always have to be inside the ellipse. I don't know exactly where those are just yet, but I know they have to be inside the ellipse, and they have to be on that focal axis, which in this case is running horizontally. So I know to put those out here to the left and right of the center and not above and below the center, because they do have to be on that focal axis. We have what's called a major axis, and that is the distance from vertex to vertex. So it's called major because that is the long one. Okay, from vertex to vertex, that is major axis. The minor axis is this short one here that goes from co-vertex to co-vertex. So when we're asked to tell the length of those, we will be really picking out how far it is from vertex to vertex and co-vertex to co-vertex. All right, one more thing that is neat about an ellipse, there is a Pythagorean relationship, and this formula will be given to you on your formula sheet at the end of the semester when you're taking the North Carolina final exam in pre-calculus. You will be given this relationship here, this Pythagorean relationship, and it will even be labeled ellipse, so you'll know exactly where to find it. This tells you the C, okay, and the C is the focal length. So the a squared and the b squared are the bottoms of the fractions. The c is the focal length. Now, if you know what that is, which is the length from the center to a focus, the length from the center to a focus, then you will be able to write the the coordinates for the foci, which is what we're going to be asked to do in a lot of these problems. So there is your Pythagorean relationship. Alright, this slide is a good reference slide. If you get to the problems on the assignment and you have trouble figuring out how to take all the numbers and write them as coordinates, this slide will help you. But we're going to move on to our first example. Example 1 says graph the ellipse, then find the vertices and the foci. And we're going to do a little more than that. We're going to throw in a couple extra things so that you're prepared for how to do these on your homework. This, first of all, this equation is not set equal to 1 like I said it always had to be. So we are going to have to fix that. And you're going to run into this quite a bit. We're going to have to divide the entire equation by 36. Alright, and I'm choosing to do that because that's the number that if I divide by on the right hand side, 36 divided by 36, that's what's going to give me 1. Alright, now to simplify the rest of it, that's going to be x squared over 9 plus y squared over 4. Alright, so the first thing I want us to pick out is the center. Remember, center is the HK, and those are the numbers in the parentheses with the x and the y. In this case, there are no numbers in the parentheses with the x and the y, so our center is just 0, 0. And let me go ahead and plot that on my graph. Right there, the origin, that's going to be the center of my ellipse. Now, this 9, remember that is our a squared value, and a is the x direction radius. So if we square root that number, we're going to get 3. That tells me the x direction radius, and again it's underneath the x term, the x direction radius is 3. So I'm going to go from the center out to the right 3. I'm going to go from the center out to the left 3. Those are 2 points that are going to be on my ellipse. My ellipse is going to go through those 2 points. And then same idea with the y direction radius. The y direction radius squared is 4, so that means the y direction radius is 2. So from my center up and my center down, we're going to go a distance of 2. So notice how those were different numbers. And so when I sketch this in, what I have is an ellipse. Okay, so let's go ahead and name the vertices. Remember, these are the points that are furthest away from our center. Alright, so in this case it's going to be 3, 0 and negative 3, 0. And then our co-vertices are the points on the ellipse that are closest to the center. That is 0, 2 and 0, negative 2. Alright, let's go ahead and talk about the length of the major axis and the length of the minor axis. Major axis goes from vertex to vertex, so from negative 3, 0 to positive 3, 0. That is a length of 6. And then the length of the minor axis, remember this is the minor axis, that has a total length of 4. Once I have that ellipse graph, that is very easy to pick out. Now, one final thing that we have to do is to find the coordinates of the foci, and I intentionally left this for the end because we're going to have to use that Pythagorean relationship that we talked about just a minute ago that said c squared equals a squared minus b squared. Alright, so if we plug in those numbers, and in this case, the 9 is our a squared, the 4 is our b squared, so we're going to plug those in. That's going to say 9 minus 4. Notice how I did not square those numbers. These are already a squared and b squared, so we plug those straight in. And then one other note right here, if I ever start to plug those in and I realize that that's going to be a negative, remember we're trying to find a focal length, so we do not want to try to do square root of a negative. We're going to have an imaginary number for our focal length. So if it turns out that you plug in a squared and b squared and you're going to get a negative number, just switch them around. In that case, do b squared minus a squared. Alright, so to finish this math up, c squared equals 9 minus 4 is 5. And then to square root that, we're going to get square root of 5. And again, because we are dealing with a length or a distance from the center to each focus, we're going to only worry with the positive one. We're not going to worry with the negative one. Alright, so remember what that tells me. That is the focal length, which is the distance from the center to each focus. And square root of 5 is a little over 2. So let's estimate right there. So from center to focus is square root of 5. And then I also have one over here somewhere. and that's another distance from center to focus of square root of 5. So if I'm writing those coordinates for the foci, the first one, let's do the one over to the right, doesn't have a coordinate of 0, 0. It has a coordinate of square root of 5, 0. And then the one to the left has coordinates negative square root of 5, 0. All right. Let's look at a second example. This one says find an equation of the ellipse with foci 0, negative 3 and 0, 3 whose minor axis has a length of 4. So this time we're asked to write an equation with that given information. We're given us two foci and the length of the minor axis. All right, so let's go ahead and plot what we have. 0, negative 3. I'm going to put a dot there. That is one of our foci. 0, positive 3 is the other focus. All right, so my ellipse doesn't actually go through those points. Those 2 points are not on my ellipse. Those are inside my ellipse. All right, so we'll have to be careful not to draw our ellipse through those points. But it also tells me the minor axis has a length of 4. Remember, the foci are always on the major axis. So the major axis is going to run this way, which tells me my minor axis is going to run horizontally. So if that has a length of 4, then from the center to the left and to the right is going to be a distance of 2. Now let me back up for a second. How did I know that the center was at 0, 0? Well, it has to be halfway between the foci. So we know that if this one's at 0, 3 and this one's at 0, negative 3, then halfway between that would be 0, 0. So I do know my center's at 0, 0. All right, so to sketch in the graph of this ellipse, it is going to go through these 2 points on the side. But remember, I need to miss those 2 foci. It does not go through those 2 points. All right, let's see what we can do with writing the equation. I already know the center, so if I'm plugging in, I'm going to have x minus 0 squared, and I'm going to have a y minus 0 squared. We'll worry about the bottoms and the fractions here in a second. And we know that it has to equal 1. Now, simplified, let me go ahead and do that. That's just x squared, and that's just y squared, but I wanted you to see where we got that. We plugged in 0, 0, because that was the center. Now, I already know the x direction radius. From the center to the right and center to the left on the x-axis is 2. So if I plug that in and square it, this x bottom of the fraction is going to be a 4. Now that is just coincidence that it's the same thing as the length of that minor axis. It is actually 2, the only number that those will be the same. So we did not get the 4 by taking this 4 and plugging in. We actually had to think about what that x direction radius was squared. It just so happened that that was the same thing. Now the y direction radius is not 3. Okay, that's the focal length. We need to use that Pythagorean relationship to figure out what our y direction radius is. So remember that c squared equals a squared minus b squared. The c is our focal length, and we already know that. Our focal length is 3. Distance from center to each focus is 3. And we actually already know the smaller of the 2 numbers. So I can't put the 4 here because it's the smaller of the numbers. It actually goes over here. So we're starting to get a little careless with our A and our B, but I want you to see that that has to be a number that's bigger. So I have to put it in this order. So even though we're going to end up solving for that and plugging it in for what really is B, it will all work out in the end. So 3 squared is 9. All right, and then I would add the 4, and I get 13. So A, which I'm referring to as my y direction radius, is actually square root of 13. So when we plug that into our equation, square root of 13 squared is going to give me a 13 on the bottom. And square root of 13 is approximately 3.6, which makes complete sense that the distance from the center out to this ellipse up here and down here would be more than the 3.6 to be exact. So the answer to this question, find the equation, here it is, x squared over 4 plus y squared over 13 equals 1. Now, for your homework assignment, we will come back and do those other 2 examples, example 3 and example 4 in class. But tonight for your homework, we want you to take a look at number 1, number 7, number 9, and number 15. have those completed for tomorrow. Have fun!